Okay, so just follow along with me. You'll see how simple this really is, you guys. In a triangle, the larger side is always going to be across from the larger angle. So when you look at this triangle, just look at the three numbers because they represent the side lengths. What's the biggest number you see? Let's start there.
22.
22, okay? So obviously this represents the biggest side. Now, when you name a side of a triangle or any other kind of a polygon, you're supposed to use two letters. So I would call this side CB, or you call it BC, either way, okay? So side CB is the longest side. The longest side will always be across from the biggest angle. So what do I mean by across from? If you were to take this side and draw an arrow going away from it, what angle am I pointing at right now?
A.
Angle A. That means the biggest angle must be A. Okay, angle A is the biggest. Now, using that same logic, first of all, tell me, use your letters. Which side is the smallest side?
The 20.
AC, the 20. But we'll use the letters and we'll say AC or CA. Can everybody see that side AC is the smallest side?
What would have happened if we wrote 20?
We'll cross that bridge when we come to it. So, are you with me that that's the smallest side in blue?
Yeah.
So, what therefore is the smallest angle, guys?
AB.
Wait, the angle will just be a single letter.
B.
Well, I'm hearing multiple. Okay,
It's B.
if I draw an arrow away from the side, it should point right at the angle that goes with it. So angle B, can everybody see that angle B should be the smallest angle? Because that's the angle that's across from the smallest side. Did I lose anybody just then?
No.
Okay, so we're good. Alright, now, here's something that you weren't familiar with. You didn't know what I meant when I said write me a compound inequality. You know what an inequality is. Greater than, less than, that type of thing. A compound inequality is putting two of those in the same statement. So we're supposed to do it from least to greatest. So I'm going to start with the smallest angle, which was B. Okay, and it's the smallest, so it's definitely going to be less than something. Okay? Now, A is the biggest, but what's the angle that I didn't mention yet? Angle C. That must be the middle one. So I'm going to mention that one next. So angle B is the smallest, so it must be less than angle C, which in turn must be less than angle A. So see how I've put it all into one inequality? That's a compound inequality. Compound means you're putting more than one thing together. This would be read B is less than C, which is less than A. Okay? Always put it from least to greatest. As long as it's from least to greatest, these symbols will always be less than signs. Okay. Example 2 is almost the same thing, only backwards. Look at these numbers. Now, tell me the letter that represents the biggest angle.
B.
All right, well, I'm only hearing two people. What's the biggest angle, you guys?
B.
Yeah, that's better. Angle B is the biggest angle. You see the 61. Now, the question is, which side is the biggest side? Give me a two-letter name of the biggest side if you can. Okay? I heard multiple answers. Now, so again, if you're having any trouble just seeing it, draw yourself an arrow. If you're looking at angle B, and we all agree that's the biggest, if I took an arrow and I drew it going away from angle B, that arrow should be pointing right at the biggest side. So let's try it again. What's the biggest side?
AC.
AC is the biggest side. AC is the one that is across from angle B. So when you write sides, you should put a little line over the top of it, because that means segment AC. Okay. Now, do not blurt out this answer yet, because I want everyone to have a few seconds to process and think. I'm going to the next question. I'm asking you which side is the smallest. I'm going to give you 7 seconds to think. And then I will expect you all to respond together. So look at this picture. Silently think which is the smallest side. Okay, what's the smallest side, class?
AB.
I heard AB and AC. We already said that AC was the biggest side, so that's definitely not the smallest. So the smallest side is going to be AB. The only possible choices were AB and BC because those were the ones that's left. But I didn't hear everyone responding, so let me just make sure this is clear. Looking at the numbers, I'm hoping that it's obvious that 59 is, that angle C is the smallest number, 59 degrees. And again, if I made an arrow going across from that angle, that would be pointing right at the smallest side. That's why AB must be the smallest side. Okay? That means the other one must be the middle one. So again, I could write a compound inequality. This time, putting the sides in a row. What am I going to write first in my inequality?
Side AB.
Side AB. Okay? Because that's the smallest. Is less than. What comes next?
Side B.
Right, you could either say BC or CB, just as good. Alright, that must be the middle one because it's not the biggest and it's not the smallest. So it goes in the middle. Rodney, talk to me, brother.
What is the line above the
It means segment. Okay? So that just means it has a beginning and an end. So that would be the compound inequality that I'm talking about. Have I lost anybody yet? Raise your hand if you're lost.
No.
Okay. Alright, let's move on. Now this is a lot of words, but it really is something simple. The sum of the lengths of any two sides is greater than the length of the third side. Well, example 3 clears that right up if you had any confusion at all. Okay? So the sum of the length of any two sides, for example, A and B, if I add those up, it should be greater than C. So any two should be greater than the third. So I said that one. Somebody raise your hand and tell me another one that I didn't already say. Tell me something just like this using different letters.
A plus C.
Gracie. I could have said A plus C is greater than B. Somebody new, raise your hand. Brian.
You could say B plus C equals A.
Greater than.
A.
There we go. B plus C is greater than A. Any two have to be greater than the third. So that's example 3. Any questions?
No.
Does that have to be true?
It is true according to the theorem above it. Okay? This theorem is what we're using. The sum of the length of any two sides is greater than the length of the third side. If you took a ruler and measured this, you would find all 3 of those statements to be true. Do you believe me? Okay. We can get the rulers now. All right, look at example 4. Now, here's how I want you guys to visualize this. See the dot that I'm putting right here? Okay? I want you to picture that as a hinge. You know what I'm talking about? Like a door. So I want you to picture the blue and the red opening and closing like a door. Now, I want you to picture that third side, C, that's a dotted line. Imagine that that's a rubber band, okay, or a bungee cord or something. So it's shrinking as I close and it's stretching as I open. So here's the question. I want you to think in your mind for 5 seconds. Maybe 8. I haven't decided yet. First question is, what is the biggest possible length? Don't blurt it out. Only in the mind. What is the biggest possible length of that third side? Think about it now for 5 seconds. Biggest length of side C possible. Okay, I want you to turn to somebody sitting nearby you. Tell them what you thought and why. Go. Go. Want to hear some talking? Tell somebody what you thought.
To me, that's wrong.
Okay, so Yeah, I need to know what you guys thought. So, Alex, what did you think? What's the biggest that C could possibly be? Say again? Okay. So I got one vote for 24. Anybody think, come up with a different number? Just brainstorming, Rodney?
15.
15? Anybody come up with a different number? Scott?
23.
23? Okay. Brian? Oh, wait, no, I thought you were putting your hand down because you were repeating somebody else. You have a different number? 25. Okay, 25? 13. 13? Okay, anybody want to justify their answer for me? Rodney, tell me something.
You see the bottom one is 14.
Uh-huh.
So the highest goes 15.
Okay, so the bottom is 14, so the highest is 15. Gracie, talk to me.
I think it's 23 because it says like A plus or whatever plus B
The formula.
greater than C.
Right, okay.
Yeah.
Okay, she was saying A plus B has to be greater than C.
13.
So she's going with 23?
Yeah, because if you added A and B together, it's 24.
Okay.
So it can't be greater than C.
Anybody else have input? I like it. I understand it. Anybody else have input for me?
No, so no.
Okay. These are all good thoughts, and let's nail it down precisely. I had encouraged you to look at this like it was a hinge. Okay? So let me go ahead and treat it like a hinge. You understand that if I want C to be as big as it can be, it's going to get bigger as I open this door. It's going to get bigger, right? So far, like just then, by doing what I just did, C is bigger now. Move this around a bit. Okay? But I could keep going. I could open the door wider and wider, right? So say if I took it and I opened it almost all the way.
To a straight line.
Okay? In fact, sure. Because so far I've got this. That made it even bigger, right?
There.
It's a very shallow triangle, but still a triangle. I haven't made it totally straight yet, so it's still a triangle.
It's like 20.
But you're right. If I went ahead and took it to that last little extreme, let's see if they'll let me do this or not. I'll just have to do it like this. Whoa! Come back. Don't you mock me, my friend. Okay? If I go ahead and make it perfectly flat, obviously you can't make a triangle that's flat. So that's too big. But that'll be a useful number to have in my back pocket. What number, just blurt this out, what number did I create just now?
24.
Can you see that the entire length from one end to the other, there's 14, there's 10, that's 24. Okay? So, yes. Alex?
Question, when 23 though, so not be the biggest length, because you like
Yes and no. As far as votes go, votes for my sizes, I'm comfortable. 23 and 24 were equally valid guesses as long as you were trying to stick to whole numbers. So I'm sort of hinting at the problem with the number 23, because what about 23.5? What about 23.9? So we have to have a way of accounting for the decimals as well. So can you see that we can't get all the way to 24, because that would be a flat line. But I can't say just 23 either, because what about 23 and a half and stuff like that? So this is the best I can say. It can't quite be 24. Can anybody think of a way of saying what it can be that won't leave out the decimals? Maybe using an inequality.
Or, 23.9.
Well, what about 23.99?
Maybe round it up.
Can you think of a way of saying it?
Yes.
Go.
24. Plus. No, minus. No, plus. No.
Anything else?
One more guess, Alex?
anything less than 24.
Okay, that's what I was waiting for. Inequalities will help us. What we're looking for is anything less than 24. Can't be 24, but it can be anything less. By using the words less than and mentioning 24, we're covering 23.99999. Okay? So, so let me just jot down what we said so far. It has to be less than 24. 24. See. Okay? Now, in the other extreme, we'll get to the other extreme by closing the door. Okay? So let's close the door and see what happens. As we begin to close that door, it goes like this.
I know how to close the door.
A CS? Okay? Can you agree that I've made it quite a bit shorter?
See.
Alright? But I could make it a little shorter still, couldn't I?
See. Yeah.
Let's go all the way to that flatness extreme one more time. If I close this all the way, obviously, if I do that, it will no longer make a triangle because it's completely flat. But just like before, as long as I use an inequality, I can still use it to help me figure out what's going on. I can still use that number as a useful tool. Well, okay, you know what? I have to be careful. Because 14 is not that little blue piece, is it? Maybe I have to move this up. 14 is supposed to be the length of the entire blue piece. Okay? So remember, 14 is the whole blue, whereas the 10 is this piece right here. Okay? So the question is, if it were completely flat, which would be impossible, but if it were completely flat, what would be the length of C?
14. No, that would be a 4.
Can you see that if it were completely flat, this would be 4? Okay?
That's 10. The red line's 10.
Okay, because the entire distance has to be 14, the blue. And I've already got 10. That means the missing piece must be 4. 10 plus 4 would make our 14. Is everybody seeing it now? The missing piece would be 4. So that would be the shortest, the lower limit. Now, can it be 4?
Yes.
Can it be less than 4? So switch it around. What can it be? Mention 4 and tell me what it can be. 4 or greater. Or in fact, let's take out let's say just greater than 4. Because if we say 4 or greater, that would imply it could be 4. Because that would be flat. And that wouldn't be a triangle. Okay? So just like we had to say less than 24, we would have to say greater than 4. Or I'll be lazy and say more than... Oh, Brian. I know you're not touching that
You stepped on my
backpack.
backpack. I was picking it up.
Just simply excuse me was fast.
Excuse me, sir.
But yeah, you guys know better than to touch those backpacks. Okay, day 1. I made it very clear. So it's got to be less than 24, but more than 4. So if you wanted to stick with words, you could just say it like this. Between 4 and 24. That would be a nice compact way of saying it. So in a case like this, you know, if you add them up, that's going to give you the upper limit. If you subtract them, that's going to give you your lower limit, right? Could I write this as a compound inequality? Of course I could. Using C as the variable third side, 4 would be less than C, which would be less than 24. Okay, that would also be a nice way of writing it. Okay? All right. We'll have to leave it right there because I want to make sure you get your homework. All right, let's look at one more example. One more rule. The measure of an exterior angle is greater than the measure of either of the non-adjacent interior angles. This is all I'm saying. Look at angle 1 right here. That's an exterior angle. And then look at angle A and angle B. These are the two non-adjacent, meaning non-touching, interior angles. This theorem is just saying that the exterior angle, angle 1, is going to be bigger than angle A, and it's also going to be bigger than angle B. So that's why right here I've said the measure of angle 1 is bigger than the measure of angle A. That's one of them. write the other inequality. Well, the other one is the measure of angle 1 has got to be greater than the measure of angle B. Okay? Alright, so the exterior angle has to be bigger than either one of the angles that are on the inside. Okay, number 14. Is it possible to construct a triangle with the given side lengths? If not, explain why not. I always like to start with the biggest side length. So we've got this 32. So I like to draw a model. So let's say this is my 32. Okay. Let's see, can I make that bigger? All right. So let's say that's my 32. And then I've got this 11 and 16. Okay, so there's my 32. Now here comes my 11 and my 16. So let's say here's 11, and let's see, let me make that a little bigger too. Okay, there's my 11, and here's my 16. Okay, so the question is, will these reach? I've got 11 stretching from the left, 16 stretching back from the right. I've got 32 between them. Will they be able to meet in the middle with enough left over to form a triangle? Well, hopefully it's obvious to you that the answer is no. 11 plus 16 is 27. So that's the greatest length that could be made. If these stretched all the way towards each other, they just would not reach. Okay, so say this 11 stretched all the way down like this. You know, worst case scenario is flat. And say if this 16 came all the way down. Okay, so that's 16, this is 11. There's no way that those are going to reach because 11 and 16 only make 27, but the distance from one end to the other is 32. So there's always going to be this gap in the middle. So there's no way they're going to make a triangle. So if you always hold that picture in your mind and you always start by looking at the larger side, then you can just think of it in terms of the smaller two have to be bigger than the biggest side, the third side. Okay, so as far as an explanation for the no, you can say 11 plus 16 equals 27. This must be greater than 32 to form a triangle. Okay, so that's why that one was a no. Now let's go ahead and take a look at number 16. Describe the possible lengths of the third side of the triangle given the lengths of the other two sides. So this is very much like the problem that we did when we did example 4. Remember, basically, remember how we were treating this like a hinge, and the shortest that this third side could be is going to be the difference between the two. 14 minus 10 was 4. So this is a picture of the shortest it could be. The longest it could be is if I took it and I stretched it out completely in the other direction. If my 10 was here. That's as long as this could be, because now it would stretch like this all the way from one side to the other. And then 14 plus 10, that's 24. That's how we got the upper limit. Okay, so to review, visually, the upper limit is going to be gained by adding the two sides that you have, and on the other hand, the lower limit is going to be reached by subtracting the two sides that you have. Okay, because it's going to be like this. Okay, so we're adding and subtracting to get the two extremes. So looking back at this problem, we could look at it this way. We've got the 8, and then we've got this 3. So here's my 8. Okay, let's say that's the 8. Let's make it a little bit bigger. Okay, that's my 8. And say this is my 3. Okay, so I got my 8 and my 3. So this is my 3, and this is my 8. Okay, now this third side that they're talking about would be like this. This is the third side in question, which I like to call C, side C. Okay, so the question is, what are the possible lengths of C? The bottom line is going to be, if we add these, we're going to get the upper limit. If we subtract these, we're going to get the lower limit. So 8 minus 3 is 5. So 5 is going to wind up being my lower limit. Okay, so 5 is going to be less than C, which is less than. If I add these, 8 plus 3, I'm going to get 11. So 11 is going to be my upper limit. So this is a description of the lengths, the possible lengths of the third side. Or in words, you could say between 5 and 11. That works just as well. Okay, and just one more time to be thorough. The reason I really do not want you just to memorize, oh, you add them, you subtract them. That's where the numbers come from. I will be much happier if you can understand this visually the way I'm trying to show it to you. We're going to get that lower limit because this third side gets smaller and smaller as this becomes closer to being flat. Okay, so if I put this side of length 3 all the way down like that, that makes this side C as small as it could possibly be. Okay, that's C as small as it can be. If the whole thing is 8 and this part over here is 3, that means the other part must be 5. Okay, so this piece C must be 5 when it's flat like this. That's the lowest it can possibly be. On the other hand, if we stretch it out in the other direction, okay, if I take this 3 and I move it completely in the opposite direction, okay, so now there's my 8 and there's my 3. Now this C is going to be what you would get, because now C has to stretch from one end all the way to the other. That's why we're doing the sum, because that's what it would take to reach from one end to the other, And that's the case where C would have to be 11. Okay, so hopefully you truly understand number 16. So to make a triangle with our 3 not flat in the short way or the long way, C is going to have to be numbers between 5 and 11. So it would have to be numbers like 6, 7, 8, 9, or 10. But don't forget, between 5 and 11, that includes numbers like 5.5, and it includes numbers like 10.9. Okay, so this C, when the triangle actually forms looking like this, it could be anything in between, all the way down to 5.0001, all the way up to 10.9999.